Hello and welcome everyone to yet another exciting session of TestMu Conference 2023. I'm Shantanu Wali and I will be your host for this session, Chrome Loves Testing. During this session, we will overview the Chrome team's recent endeavors to better support testing and automation use cases. Specifically, we'll dive into Chrome for testing and the new headless mode of Chrome. However, before we move on, let's take care of a few pointers. We will have a dedicated Q&A section towards the end of the session. So if you have any questions, feel free to add those questions to the Q&A section, which you can see on the right of your screen. Secondly, the session is being recorded. So in case you need to drop off midway, you'd be able to rewatch the entire session from the view schedules option on the top left of AirMe. And lastly, just to make sure that the session is more interactive, you can make use of the emojis on the bottom of the screen. I can see a few of them already coming in. Now, join me in welcoming our speaker, Mathias Bynens, who hails from Belgium and has been working with Google as a staff software engineer. He's specifically been working on Chrome DevTools. He is a web standards enthusiast, and his interests lie in HTML, CSS, JavaScript, Unicode, performance, and security. Thanks for joining us, Mathias. Over to you.
All right. Thanks for the lovely introduction. So indeed, my name is Mathias, and I work at Google on the Chrome tooling team with a focus specifically on browser automation. So my team works on projects like Chrome Driver, Puppeteer, and also some aspects of Chrome DevTools. And then there's a few other projects that I will be talking about today. I'm really excited to tell you about some of our most recent efforts on the Chrome team to make web testing more reliable in particular. So after a brief introduction, we are going to discuss two separate projects. The first is Chrome for testing, and the second is Chrome Headless, and specifically the new headless mode. If there is time at the end, we can do a Q&A. If time runs out and some of the questions cannot be answered in time, then don't worry, I will take care of that offline after the session. And also, if you think of a question or you have some feedback for me later, I'm always happy to chat. So just ping me on Twitter or send me an email. I'm really happy to hear what you have to say. And without further ado, let's get right into it. Let's start with the motivation for this work. Why does the Chrome team care about web testing? Well, we know that it's difficult to set up an adequate environment for automated browser testing. So much so that it's consistently reported as a top developer pain point for web testing in industry-wide surveys. This particular quote comes from the MDN, the Mozilla Developer Network Web Developer Needs Assessment. So we have actual data backing this up. We know that this is true. So on the one hand, this sounds really bad because we know that testers and developers are suffering from this pain point. But on the other hand, automated browser testing happens to be what my team works on. So addressing this pain point is actually a huge opportunity for us. We have the opportunity to meaningfully move the needle and make things better for all of you. So let's think about that for a second. What is the very first thing you need to perform any kind of web app testing at all? That's right. You need a browser binary. You need an executable in which you can test your web app, right? So let's say you want to test in Chrome. Where would you even start with that? Well, chances are you already have a Chrome browser installed on your system. It might seem very tempting to just use that same Chrome binary for your testing needs. However, this is not a great solution, and here's why. Google intentionally doesn't make versioned Chrome downloads available because users shouldn't have to care about version numbers. They should always get updated to the latest version as soon as possible. So when you download Chrome, you just download it. You don't have to select a version number first as a user. And this is great for end users, but at the same time, it can be a little bit painful for developers and testers who sometimes need to reproduce a bug report in a very specific Chrome version, which might be an older version. One of Chrome's most notable features is its ability to auto-update itself. End users are really happy to know that they are running an up-to-date and secure browser version, including modern web platform features, browser features, and bug fixes at all times. However, as a developer or tester running a suite of end-to-end tests, you might have an entirely different perspective. You might want consistent and reproducible results across repeated test runs. But this may not happen if the browser binary decides to update itself in between two runs, because then you're testing against two different targets. Secondly, you might want to pin a specific browser version and then check that version number into your source code repository so that your teammates can use the exact same version during their testing and actually get the same results as you. Also, this version pinning makes sure that you can check out old commits and branches and then rerun your tests against the browser binary from that point in time to reproduce the results from at the time. And none of these very reasonable, very common scenarios are possible with an auto-updating browser binary. And this is the fundamental mismatch between what's good for regular browser users versus what's good for developers doing automated testing. So long story short, while regular Chrome may be adequate for basic testing needs, it's not always ideal for more complex scenarios. To try and work around these issues to some degree, we know that many developers and testers download Chromium binaries instead. Unlike Chrome, Chromium binaries do not auto-update, and they are available as downloads for older versions. However, these Chromium binaries are actually snapshots, and they were only ever meant to be used for Chromium development, not for actual web app testing. So this is a different kind of fundamental mismatch, which presents a few issues of its own. So first, these Chromium binaries are not actually reliably available across all the platforms you care about. A Chromium binary for a specific revision might be available for Mac, but not for Windows, for example. This makes it difficult, or in practice often impossible, to test exactly the same Chromium version across multiple platforms. And to give you a concrete example of just how painful this is, here's a script that we used to roll new Chromium versions into Puppeteer. This script made an API call to get the latest known revision and then started checking if a Chromium binary was available for that specific revision for each supported platform. If not, it would decrease the version number, the revision number by 1, and then just try again. So it kept going in this kind of brute force manner until it found such a lucky revision with downloads available across all the supported platforms. And yeah, this sounds a little bit ridiculous, right? And that's because it is. This is a little bit like playing the lottery. There's nothing in place that guarantees that such a lucky revision even exists within the range that you're looking for. And even if you're lucky enough to find one, then there's still no guarantee that it's anywhere close to the Chrome version that is shipping to real users, which is ultimately the version you want to test in. Second, these Chromium binaries are built and published completely separately from the actual Chrome release process, which makes it impossible to map their versions back to real user-facing Chrome releases. So let's say you want to test in a Chromium binary that corresponds to the latest Chrome stable release, which is a very common and very reasonable use case, right? Chances are that this is simply not possible because the Chromium binary for that version likely isn't available for download. You'll have to find a different Chromium version that's as close as possible and then use that instead, which is not only annoying and difficult to do, but it also results in a slightly different browsing experience with potentially different features and bugs present because you're fundamentally testing two different versions. And then finally, Chromium is also different from Chrome. Even if you manage to magically get a Chromium binary that's built off exactly the same commit as a user-facing Chrome release, it's exactly the same version, then there's still going to be differences between the two, which may impact your testing. For example, if your web app relies on proprietary video codecs that are shipping in Chrome, then you're going to have a bad time testing in Chromium because Chromium doesn't support those codecs, and it never will because it fundamentally cannot support those. In summary, for web app testing, Chromium is not the greatest option either. Luckily, there is some good news as well, because we recently shipped a brand new solution to the problems that we just mentioned. This solution is called Chrome for Testing, and it's a dedicated flavor of Chrome targeting the testing use case. Concretely, it has no auto-update, so that testers can rely on it for consistent and reproducible results across repeated test runs. And also, it's integrated into the Chrome release process, and it's made available for every Chrome version that gets released to end users across all release channels. So that's across stable, beta, dev, and canary, and also across all the supported platforms, including Windows, Mac, and Linux. Chrome for Testing provides you with a versioned binary that's as close to regular Chrome as possible without negatively affecting the testing use case. So it's just different enough from Chrome in just the right ways. At this point, you might be thinking, well, this sounds great. How do I get Chrome for testing? And that's a really good question. But I'm going to start by telling you where you cannot get it, because we intentionally do not list Chrome for testing on the Google Chrome download page. And that's because it is not meant to be used for regular browsing by regular users. It is really only meant to be used for testing use cases by experts such as yourselves. With that disclaimer out of the way, the easiest way to download Chrome for testing binaries for your platform is by using our Puppeteer browser's command line utility, or CLI. It's available via NPM. So here's an example where we're downloading the latest available Chrome for testing binary corresponding to the stable channel. Here's another example where we specify an explicit version instead. So this is version pinning, what we talked about before. It's very useful in situations where you want to pin the version and maybe check that version number into your source code repository so that your whole team is testing against exactly the same version. It also enables you to check out old branches and old commits and then rerun the tests like they were at the time against the browser binary from that point in time. Another thing you can do is just specify the major version if you don't care about the exact version, but you do need a version within this milestone range. In this case, I'm passing 116. The tool is then smart enough to figure out the latest available version within that range and then downloads and installs that. Now, if for whatever reason you don't want to use or you can't use the Puppeteer browser's package, you prefer to build your own automated scripts for downloading these binaries, we've got you covered. We officially support that because we offer JSON API endpoints with the latest available versions per Chrome release channel. So that's for stable, beta, dev, and canary. Among many other things, there's a JSON API endpoint for everything you could possibly want to do with these binaries. We've also built a Chrome for testing availability dashboard, which provides a quick overview of the latest status. It shows you the latest available versions per Chrome release channel and also the download URLs per binary and per platform. And of course, all of this data is also accessible via the JSON API. We believe that Chrome for testing eliminates several of the pain points that developers and testers have struggled with when it comes to setting up their environment. At the same time, we are aware that there are still other difficulties related to browser testing. For example, if you want to automate browser testing with WebDriver, say, then there's another obstacle. Because after you've downloaded your Chrome browser binary, you still need a correspondingly versioned Chrome driver binary to ensure that these two binaries are compatible. And just to show you how painful that was, let me walk you through an example. Let's say you managed to download a Chrome 114 binary with this exact version number. Maybe this is a regular Chrome binary, or maybe it's a Chrome for testing binary, or maybe it's a Chromium build that corresponds to exactly that version. It doesn't matter for the purpose of this exercise here. But either way, you have a binary with exactly that version, and now you want to get a Chrome driver binary that works with this exact version of Chrome. Here's what we instructed developers to do in this situation. You were supposed to take the entire version number, which consists of 4 parts. It's the major, minor, build, and the patch number. And you're supposed to remove the last part, the patch number, and then add this prefix to turn the whole thing into a URL. This URL then takes you to a text file that contains the latest Chrome driver version in that range. So in this case, the Chrome driver version we want is apparently patch version 90. So just to recap, we started with a Chrome binary, which patch version 69. And after this whole version mapping song and dance, we learned that Chrome driver with patch version 90 is apparently the best choice, or at least the Chrome driver version most likely to be compatible with this particular Chrome version. None of this is obvious, right? This is very surprising. There's no clear mapping between these two version numbers. They're different versions. And that was pretty painful to do. It was a lot of steps that we had to run through. Now, luckily, there is a better solution to this now. Because starting with milestone 115, we've integrated Chrome driver into the Chrome for testing infrastructure. What this means is that it guarantees that for any user-facing Chrome version that gets released, both a Chrome or Chrome for testing binary and a Chrome driver binary are made available. So basically, this allows you to now pick a version and then just download both the corresponding Chrome and Chrome driver binaries. Both the binaries are built off of exactly the same commit in the same code base. They share the exact same version numbers, and they are guaranteed to be compatible. It's no longer an implicit kind of loose compatibility thing. So this completely removes the need for developers and testers to perform any complicated version mapping. Instead, now you can just choose the version you want and then download all the corresponding binaries that you need, and that's it. So we now also report the availability of Chrome driver binaries on the same Chrome for Testing dashboard. And of course, our JSON API endpoints include the relevant information about them as well. And you might have seen this one coming. You might remember the Puppeteer browsers CLI that I mentioned earlier. It allows you to easily install browser binaries, but guess what? You can also use it to install driver binaries. So you can use it for both the Chrome browser and the Chrome drivers. Using exactly the same command as before, we just replace Chrome with Chrome driver, and it works the way you would expect it to work. So here we're installing the latest stable Chrome driver version. Similarly to the earlier examples, you can install versions that correspond to a release channel or to specific versions, or you can just specify the milestone and let the tool find the latest available version for you. Everything just works the way you would expect it to work. For more information about Chrome for testing, you can check out our blog post on developer.chrome.com. Now, okay, let's assume that we've overcome all of the obstacles that we've talked about so far. So we managed to grab a suitable Chrome binary and the matching Chrome driver binary. And now we're ready to run some automated scripts. Yay! Well, to do this, the thing is you probably want to use Chrome's headless mode. And probably most of you are already doing this for your automated tests. Headless mode lets you run the browser in an unattended environment without any visible UI. This is perfect for automated testing. And headless mode is actually nothing new. It's been available since Chrome 59, which was released in 2017 already. And it's a really popular choice for browser automation through projects like Puppeteer or Chrome driver. But guess what? There are some challenges with Chrome headless, and it's surprisingly easy for testers and developers to run into them. So for example, imagine you're testing an internal web page that depends on you having a certain Chrome extension installed. This is extremely common at Google, for example. Or maybe you're a Chrome extension developer and you want to test whether your extension works correctly by testing the impact that it's supposed to have on a web page. Either way, you now have another problem because Chrome headless doesn't support extensions. And the reason for this is technical and a bit historical as well. The old headless implementation was actually a separate, completely alternate browser implementation that happened to be shipped as part of the same Chrome binary. It doesn't actually share any of the Chrome browser code. So as you might imagine, implementing this separate headless browser came with a lot of engineering overhead, but that wasn't the only problem. Because headless was a separate application layer, it was a separate implementation, it also had its own user-facing bugs and features that weren't present in the regular or head-full Chrome. So for example, headless didn't support browser extensions, but there were other problems, like features like BF cache behaved differently, which interacted with tests in different ways. So this created a very confusing situation where any automated browser test might pass in head-full mode, the regular mode, but then fail in headless mode, or vice versa. So either way, this was a major pain point for automation engineers. And as the emojis show here, even within the same Chrome binary, headful and headless came with different bugs and different features as well. And that's why we recently shipped the brand new headless mode in Chrome 112 earlier this year. In this mode, Chrome creates but doesn't display any platform windows. So it's literally the real Chrome browser, it's just invisible. And this is what everyone already was expecting headless to be, right? It's kind of weird that it wasn't, but now it's finally true. So this means that all Chrome browser functionality, existing and future functionality, is now available with no limitations in the new headless mode. This completely eliminates the entire category of problems that we were mentioning earlier. Headless and headful are now truly the same browser, which finally meets user expectations and removes countless surprising differences. This launch marked the culmination of almost 2 years of work on our team, completely re-architecting our approach to headless. And this new headless implementation is part of the Chrome application layer. So it actually shares the Chrome browser code. It is literally the same browser. So what's interesting here is that the new headless and the old headless, one is not necessarily better than the other. It kind of depends on your use case. And there are use cases for both of them. Because the old headless mode is actually a very thin, lightweight wrapper around the Chromium content layer. It has substantially fewer dependencies than the fully fledged Chrome browser. And as a result, it's also a little bit more performant when it comes to things like startup or shutdown than the Chrome browser. This makes it very suitable for use cases like automated screenshotting or PDF printing or web scraping, for example. The new headless mode, on the other hand, is the real Chrome browser. It's the real deal. And as a result, it's a little bit more authentic, it's more reliable, and it offers more features such as extension support. This makes it more suitable for high accuracy end-to-end web application testing. So again, I'm not saying one is better than the other because that's impossible to say. I'm saying that there is a trade-off between performance and authenticity here. And which headless mode is most fitting for you is going to depend on your use case. Developers and testers who don't require the full Chrome functionality for their automation use cases, maybe they don't depend on extensions and things like that. In those cases, you might be fine with the old headless mode. Maybe that's sufficient. But in other cases, you now have the option to use the new headless mode, and that's likely the best choice. So to use the new headless mode, all we have to do is to pass the headless equals new command line flag. Popular browser automation projects such as Puppeteer and Selenium WebDriver already support this new headless as well, and they have user-friendly ways to opt into this without having to specify the command line flags manually. You might have noticed that the way to opt into the new headless mode is to specify headless equals new, and headless equals new implies the existence of headless equals old, right? And indeed, that's how you can still get access to the old headless mode for now. However, we plan to completely remove the old headless from the Chrome binary before the end of the year, because this would save over 1 megabyte of binary size. And as we mentioned before, it's technically a separate browser that we're shipping in the same executable. It's kind of weird that we did that. So this last line of code on the slide here will stop working in the very near future. To prepare for this removal, though, in milestone 118, we're making this old headless mode available as a separate standalone binary called Chrome Headless Shell. And we're making it available via the Chrome for Testing infrastructure. So instead of passing a command line flag to the Chrome binary like you did before, instead, you can just invoke the standalone Chrome Headless Shell binary directly. Everything else still works the same way. And you guessed it, the Puppeteer browser's CLI supports installing the Chrome Headless Shell binaries as well. So whether you need new headless, which will be part of the Chrome browser and is already part of the Chrome browser binary, or the old headless mode, which is now called Chrome Headless Shell, you now have the option to choose between them, and you can just as easily install either of them. And it's going to depend on the use case that you have. For more information on headless in particular, you can check out our public announcement on developer.chrome.com. And in summary, thanks to Chrome for Testing infrastructure, every single user-facing Chrome release now gets a corresponding release of Chrome for Testing, which includes a number of binaries. It's Chrome, Chrome Driver, and Chrome Headless Shell for each of the supported platforms that you see there on the right. We believe that this is a major improvement for developers and testers, and we're hopeful that this helps address the pain points around setting up a suitable environment for browser testing. In addition to our own Puppeteer browsers package, we're already seeing popular ecosystem libraries, frameworks, and tools integrate with Chrome for Testing as well to simplify their user setup while simultaneously offering more reliability and new functionality. Selenium Manager, Selenium Base, WebDriver.io, WPT.FYI for the Web Platform Test Project, those are just some examples. So I urge you to please try out Chrome for Testing, either directly or through your favorite tool, which you're already using, and let us know how it goes. I'm eager to hear your feedback. And that's it for the presentation. Thank you for listening. If you have any questions or feedback, let's go through some of the questions here. And as I mentioned, if you have questions later, don't hesitate to email me. Thanks.
Thank you so much, Mathias, for that insightful session. And I think we have a lot of questions coming in as well. So let me just start with a few of them. how can Chrome browser features enhance testing processes and outcomes? And along with that, we also have a relevant one, which is what techniques do you use?
Oh, okay. Let's start with that first one. This is a very open-ended question. I think, how can Chrome browser features enhance testing processes and outcomes? So when it comes to specific web platform features that require testing, it's my team is part of the crew that implements the backend support in the Chrome browser to make things testable. For example, on web applications, it's possible these days to implement light mode or dark mode support. This has been possible for a few years now. But at some point, someone had to implement support for automatically configuring that setting so that it can be emulated during an automated test. And so I think the answer to this question from the perspective of new web platform features is we need to keep on top of new features that are shipping in Chrome. If they're new web platform features, they also need proper testing and tooling support so that not just can they be manually tested, but they can also be automatically tested.
Thank you so
And
much for
what
that.
was the other question?
Right. It was what techniques do you use?
Wow, that's also a very open-ended question. Yeah, if you can get more specific than that, maybe shoot me an email and I would be happy to discuss this a little bit more. But yeah, I'm not sure how to answer this.
Right. We have another one, which is what are the popular Chrome extensions for test automation?
Mm-hmm. This is an interesting question. So one of the things that my team has worked on is the recorder functionality within the Chrome DevTools. So there's a recorder panel in Chrome DevTools that lets you manually perform a user flow on a web page and then record the steps. And then later you can replay the steps, but also you can export those steps as, for example, a Puppeteer script. And extensions can be created that add their own export item to the recorder panel in DevTools. So you can export to third-party services like Cypress or Sauce Labs, for example, because they provide extensions that integrate with the recorder panel. And more recently, we also added support for replay extensions. So not only can you export, but you can actually replay right in the browser, right in DevTools, depending on the support that this extension provides. So personally, I'm very familiar with the examples that I mentioned because, yeah, we worked with these teams and they integrate with our recorder panel. But I'm sure there's many more Chrome extensions that are commonly used for test automation. I would love to hear some examples from you as well. What are the best practices for testing real-time data updates and interactions within web applications running in the Chrome browser? So if I understand the question correctly, you're talking about a web app that maybe uses something like the Fetch API or even a WebSocket connection to continuously update or dynamically update the content of the page. Yeah. Again, a very open-ended question. I would say try to figure out the parts of the web page that you can rely on. So if you know the target container where the content gets updated, you can write your test, your automated test in such a way that you just compare that the content changes when a certain action is taken without necessarily caring about the details of the content itself. If there are certain invariants about the content, like you expect it to follow a certain pattern, or maybe there's a regular expression that you can apply to it that you expect it to match, then you can hard code that as part of your script. But this is very application specific, as you say. And yeah, it requires deep knowledge of the website itself that you are testing.
Right. I think we're just about, the time has reached almost to end the session, but I think we can answer one last question as well. And this is an interesting one here.
Can you provide information on any limitations that are known with Chrome for testing? Yes, this is an awesome question. One example of the limitations is actually something I mentioned in the talk, which is proprietary video codecs. In Chrome, you can play H.264 video. We want to bring this to Chrome for testing as well, but it hasn't happened yet. Yeah, there's a bit of a process. There's an open tracking issue. You can find it on the repository for the dashboard, actually. There's a reference to it. We're working hard to make this happen, hopefully soon, but we're not quite there yet. Another limitation is on Windows, the Chrome release process involves A/B testing builds. So sometimes you have different versions of Chrome on Windows than you have on Mac or Linux, for example. And it's possible to have different version numbers that are actually built off of the same commit. So they have the same Chromium revision, but a different version numbers. And that's just to make it easier on the backend side to test, to get the results of A/B tests and to compare which experiments are enabled in which binary and to get the results that way. And right now, Chrome for testing does not we don't support releasing all the binaries for these A/B builds that happen on Windows. This is not as much of a problem in practice. If you use Chrome for testing, you can use our JSON API endpoints to find the latest available version, which has full downloads available. Right now, sometimes that will be a slightly lower version than what is available on Windows, because you're getting exactly the same version. It's just not the same version number because of the A/B testing that's happening. But also, we're working on making this happen.
Right. Thank you so much, Mathias, for that. And if there are any questions which have not been answered yet, you can head over to Lambda Test community channel. There's already been posted on the chat. And we'll keep a thread open for this talk, and we'll be answering all your questions in that thread.
Awesome.
As we conclude this session, I would really like to thank you, Mathias, for sharing your wonderful insights. I hope everyone has enjoyed this session as much as I did. In case you join in the middle of the session, you can look back on the entire recording from the View Schedules button on the top left of your screen. And thank you, everyone, for joining in. Happy testing and have a great day ahead.
Thanks, everyone. Take care.